Welcome to the Bielik method, where today we have three systems of equations. Now, what makes a system is the fact that it has more than one equation. We have two equations in each one of these. Now, what I'm going to be showing you what to do today is how to decide what the smartest choice and which method to use in solving. Okay, so I have three and I'm being asked to solve each one of those. How do you solve a system of equations? I could graph, I could substitute, or I could eliminate. But how to know which one to choose is where smart mathematicians really take their time. They're going to look it over and they're going to make a smart decision, a decision that's going to make their life easy and probably going to make it the quickest, easiest route to get to a solution. So each one of these systems is very different. And if it were me taking a test and these were the three systems I was given, I would attack each one differently. Okay? One of them I would graph, one of them I would use the substitution method, and one of them I would use the elimination method. Now, if you tuned in to previous videos that I have posted, you should know all three of those methods. Okay? So taking a peek at each one, I'm going to explain to you why I would use the method that I would choose, and I'll give you a quick rundown and we'll at least kickstart them off. I'm not going to solve them all the way out, but I will show you where I would start and how to begin. Okay, so looking at this first one, each equation is written in what's called slope-intercept form. Y equals mx plus b, meaning I have a slope and an intercept, which means I have a starting point and I have directions that tell me how much up and over or down and over to move. Okay, so for this first one, I would use what's called the graphing method. For the specific reason that it's written in slope-intercept form. The second system that we're looking at here, I would use what's called the substitution method. The reason I would choose the substitution method for this one is because I already have a variable x that's been isolated. It's given to me all alone on one side of the equal sign, meaning I have what in my video you would understand as a sticker. Okay, so for that one I'm going to be using the substitution method. And for my third and final, just process of elimination, pun, you get that, we would be using the elimination method here. The elimination method specifically because looking at these two terms here with the p attached, I can remove them using addition. If I were to add everything together, that would eliminate my p values. Okay, let's go through each one of these. I'll give you a quick rundown on how to graph them. It's going to be very fast, so you can try and follow along, but if you're stuck and not understanding something, go back and please watch one of my previous videos where I teach each one of these methods in detail. First one, both are in slope-intercept form, so I would have a coordinate grid where I would then mark my y-intercept positive 10 to start, and I would use my slope, which is a negative 3, meaning I'm going down and over, down 3 over 1, down 3 over 1. I would do that a couple of times until I have enough dots to make a line. My first line would look like that. I would then graph my second line, which would start at negative 2, where I would be going up 1 over 1, up 1 over 1. My second line would look something along that line, get it? And that point right there is going to be my solution, the intersecting point. This one, I would be taking my sticker, peeling it off, and plugging it over the x variable in the second equation because the sticker is equal to x. So here I would get 4y plus 5y, which instead of the x, I'm going to be writing down the sticker, 5y plus 1 equals 10. Now from there I can solve for y, which I would get 9y plus 1 equals 10. Take away the 1. I now have 9y equals 9. Divide by 9, divide by 9. We know that y is 1. Then I would take that 1, plug it back up into one of the equations to find my x. And last but not least, through addition, we are going to eliminate the p's. Okay? I then would get 8m equals 48. 48 divided by 8. And we're going to get our result. Ding, ding, ding. M is equal to 6. Take that 6, plug it back up here into one of the m variables, and you can find your p. Okay, these are my choices on how I would graph them. Now, by no means is this the only way to solve these systems. You can solve this through substitution. You can solve it through elimination. I personally, as a math teacher, would just recommend taking the slope-intercept form graphing route. Okay, substitution method. This one is the best recommendation that I would give. You don't have to listen to me. I'm just a math teacher. It's not like I know what I'm talking about. Okay, but if you choose to use another method, it'll still work. You just might find yourself coming into some situations that get a little trickier than others. Okay, so please take my recommendations, use them for what they're worth, and good luck on your upcoming systems of equations test.